I'm Ahmed. I'm a master's student with the Department of Cell and Systems Biology. Mostly do genetics and genomics stuff. And I use Python quite a bit alongside R and Bash in general. So today's lesson kind of differs from our usual stuff in that it's an intermediate topics lesson. So in a sense, I am, and I'm glad to hear from most of the introductions that people are familiar with Python programming in general, because this is not going to be an explicitly beginner lesson. I'm kind of going to assume you're familiar with stuff like for loops, conditionals, variables, lists, indexing. So is everybody mostly cool with that? Because if not, like, feel free to shout something out and I can try to explain it real quick. But I won't be going in depth about more basic fundamental stuff.
But we can still follow on.
Yeah, because I'm not going super in depth about super advanced topics. It's more when I design this lesson, it's mostly to build off. Our introductory lesson, so it doesn't go super in depth about those things. Rather, just adds on with new Python things, if that makes sense. Cool. So for the first half of this lesson, I thought that a good way to get things started, given that most, if not all of us, are grad students or involved in research in some way, was to kind of simulate the research process. So loading in a file, doing some stuff with it, trying to make sense of, and doing some operations with it in Python. So has everybody downloaded the scores.txt file in the GitHub repo for this lesson?
I'll put a link to it in the issue. So if you are on our website and you find today's event, you can find it.
If you haven't yet or don't really feel like it, that's also cool. I'll be working with it up here, but if you want to follow along, it'd be pretty great if you could download that. So who here has it downloaded already? Has it downloaded already? Okay, cool. Just a few people. So I'll give it like half a minute. You guys could do that. It's on the issue for this lesson. So,
It's not yet.
oh, not yet. Whoops. But either way, if you go to GitHub, or actually rather the UofT Decoders website, and scroll on down to events, and right here we've got intermediate topics in Python. So if you click on that, and Madeline got it just in time. So this link, there's scores.txt. If you could download that, that'd be great.
If you click raw, then you can just like copy that to it.
Yep, and make sure you put it in a folder that, like, you know which folder it's going to, because that's going to be a little important. All right, are we all on board with that? Can I move on, or does anyone need an extra second or two? Cool. Still seeing people staring at their screens. Okay. Well, I'll get started regardless. So for the first half of this lesson, we're going to be working with scores.txt. And the hypothetical situation here is that you've got these scores from, let's say you have 50 students who wrote a test. And this file contains their scores in percentages, even though the test itself was out of 40. So we want to import these scores into a Python list and do stuff with it, make sense of it, and all of that. And this is, I started the lesson with this because this is typically how the research process starts for me. It's bringing a file into Python. So the way to do that is using the OS library. So the first thing you're going to want to type is import OS, and making sure that you are in the right folder. So OS get CWD, or OS get current working directory is the way to do that. So if you're in Jupyter, Shift Enter is the way to execute something. So I can see I'm over here. And I kind of don't want to be, because that's not where my file is. So OS change directory, that's what that stands for, is my way to, yeah?
Can you just say really quick how you get into Jupyter Notebook?
Oh, right. So if you've got Jupyter Notebook installed, if you've got Anaconda, you have it already. You can go into your terminal and just type in Jupyter Notebook and hit enter, and that should do it. And you should see something like this. Is everyone cool with that? Cool. If not, you can also, if you just want to follow along in a console, you can just type in Python into your console, and that should also do it. All right. Cool. So the way to change the directory is using the chdir command, and then, so for me, I know my, the file for me is a couple folders up, so you can use .. to do that. That tells Python that I want to move one folder up. So it's on my desktop, so I'm just going to do that twice and hit enter. Then check my working directory again. I can see them on my desktop, which is great because that's where my file is. Now, reading and writing, there's two ways to import a file into Python. They're both kind of variations on the same syntax. And the classical way to do this, which I would actually advise against, to be honest, is to just use the open function, type in scores.txt, and then R. So the second argument there, so the first one is our file name, obviously. The second one is you telling Python what you want to do with this file. So R stands for read. I'm telling Python I just want to read it. If I typed in W, for instance, that would tell Python I want to write to it. And A would tell Python I want to append to it. Right now we're just going to go with R. When you do it this way, after you've done what you needed to do with your file, you typically have to remember to close it. And that's what I don't quite like. I always forget to do that. And then my session starts getting clogged. So a better way to do this, in fact, is using with as syntax, which is this, basically. Scores.txt as my file. So my file just being kind of a placeholder name. And then I can do stuff with it within this block. That way you don't have to remember to close it each time. And everything is just kind of self-contained. So the way to actually read scores into our session, I'm going to set it to a variable called scores, predictably, is to use my file, or whatever you've named your placeholder, dot read, two brackets, because this is a method. I'll get more into later on, and split. So I wouldn't worry about the specifics of this code right now. We'll be talking more about it later on. But this is how you'd load the file into Python. Everyone following along so far? Cool. And then the last thing we want to do is check that scores actually looks the way we want it to, which it does. You can see our numbers are imported into a list, and each score is a different item within the list. And that's great and dandy, and that's what we want. Some of you might notice that there are quotes around the numbers, but we'll be getting more into that in a minute. So anyhow, let's check the length of scores. Let's make sure that all 50 of our scores are within the file. The way to do that in Python is to use len, which is short for length, on scores. So we'll run that, and we notice that we have 49, which is a bummer. That means we're missing one. And so let's say we want to fix that. We want to add in our last student's score, and we go back and check, and the student got 89%. We want that in our list for downstream applications. Whoa. Okay. So how exactly can we do that? How can we add to our list? The obvious way might be to just go scores plus 89, right? That makes sense. That won't actually work because 89 is an integer, or float if you had a dot, whereas scores is a list, and Python doesn't support that. So let's just put that in square brackets. We could do that. That should work. But the thing about Python is that, alternatively, we could even go back and open the file in Notepad and type in the 89, then re-import it. But Python actually contains these built-in functions and attributes. These built-in functions called methods. So certain objects or object types have a certain set of methods associated with them that you can run onto the object, and these are often really common operations. So I think a better way to explain it is just to show it. So instead of doing that, we can have Python list out the methods that are available to us for scores by using the dir command. I love the dir command, honestly. My favorite command. No, it's not. That's one of them. This is going to list a whole bunch of things. And you can safely ignore all the ones with underscores for now. You want to scroll all the way to the bottom and look at these. So all these look like pretty helpful things. We have append, we have copy, we have index, insert, like stuff you probably would want to do to a list. And so we want to add 89 to our list. What's a good method here that kind of sticks out if we want to add something? We can see append right at the top. That looks pretty promising. We've also got extend, which also looks pretty good. We've got insert. Now instead of playing a guessing game, Python also has built-in documentation for these methods. So we can go help and scores dot append. Let's say we want to start with append, and whoops, and run that. Here Python tells us that when we run append on an object, it just appends the object to the end. Yep. Sure. Sorry, let me just shrink this output. Okay. If you're in Jupyter, clicking on this left side or using Shift-O will shrink your output. Yeah. So append looks pretty promising. We could also check stuff like extend. That also looks pretty good. Appending elements from the iterable, so I suppose for multiple objects, which isn't really what we want right now, but is also a handy method. So we'll go with append right now. The way that works is you type in the name of the object, and when you want to run a method on it, you put dot and then the name of the method. And for those of you who might have started in R or used it, you might be used to using dots within object names. That doesn't fly in Python. Python uses the period to, like you can use a period in Python to indicate a method or an attribute. So let's go scores, append 89. And bam, check the length of scores. It's 50 now. And we can look at scores itself. You'll notice that we didn't actually have to assign scores append to anything. Because methods generally function in place. I think there are some exceptions out there. So probably shouldn't make a general statement. But for the most part, you just have to run this as is, and Python will run append on scores. You don't have to assign scores is equal to scores append 89. Now, Python has these built in for any given object type. So integers have their own unique set of methods and attributes, as do strings or what have you. You can actually define a custom set of methods and attributes, so we could possibly test scores by using classes. And I won't really go into those today. We have a whole separate lesson on classes. But you know, if you want to look more into making your own custom set of methods, that is the way to do that. So anyhow, let's move on. Let's say we want to get the original scores. So here we have percentages, and we know the test is out of 40. Actually, has everyone followed along so far with the methods stuff? Cool. So we want to get the original scores out of this list. And that should be pretty simple. You just have to multiply everything by 40 or 100 or 0.4, right? So maybe a good way to start would be to check and see whether there are any methods we could use for this. So let's look at dr scores again. And nothing really pops out. No, because what we want to do the same operation every item in the list, and nothing here is really sticking out. So the next thing we might think is to go with a for loop. We could go for I in range length scores, and this is a syntax you'd want to use if you're looping over a list and you want to assign new things to it. Otherwise, you could just go for thing in list. You could go scores I is equal to scores I times 0.4. That should do the trick. And then we run that, but we get an error. Can't multiply sequence by non-integer of type float. We're not sure what's going wrong, so we'll look at scores again. A type error indicates that there's, maybe there's something wrong with our object type here. So let's just look at the type of, let's say, the first item in scores. We see this as string. This happens to me a lot in my research. You import files one way, you expect them to be one way, and they're not. We want these to be numbers. So this is quite unhelpful for our purposes. So we define these way to change these to integers. We could make a for loop again and add some conditionals in it. We could say, hey, Python, go through this list. If this item is a string, change it to an integer, and then multiply it by 0.4. So we could go for in scores, or actually, sorry, for I in range scores. If, and this is a pretty handy command that Elliot tipped me off to, is instance. Scores I. And what is instance does is it checks to see whether the first argument, and the object type of the first argument is whatever you specify the second argument to be. So what I'm basically saying is, if this object is a string, do a thing. And the thing I wanted to do is convert it to an integer, or sorry, scores I becomes integer. So this is me converting the string to an integer. Scores I times 0.4 else just multiplied by 0.4. So that's for our 89. since that's already a number. Now, we could do all this, and it should work. But there's an easier way to do this, and a way that I'm just a big fan of in general, called a list comprehension. And this is specifically for lists, as the name might imply. So the best way to, I guess, explain the list comprehension is just type one out and walk you guys through it. This is what a list comprehension looks like. So we start with the square brackets, which indicates lists, times 0.4 for each number in scores. So what this is saying is this part, for number in scores, is analogous to this, the start of our for loop. But we're telling Python, do this for each number in scores. It's doing basically the first half of this, minus the conditional and all, in one line. And if we want to put in the conditional, we can do that. We can say for num in scores if is instance, whoops, and that's valid syntax. Python won't yell at you for that. So not only does it read like a normal sentence, it's also more compact and it tells you basically the same thing. Oh, that should, whoops. I shouldn't have hit enter there, sorry. 1 second. So not only did that created a list and it multiplied everything by 0.4. So now we have our scores out of 40 instead of in percentages. And if we wanted to actually mimic this entire for loop up here, which I'll copy down so you guys can still see it, we could have been like int num times 0.4 for num in scores, just as before. Actually, no, sorry. This actually is a bit of a trip. I learned it pretty recently, thanks to Joel. But it's also apparently valid syntax. If is instance num string, else just num times 0.4, and then the for syntax, for num in scores. So it's a little trippy, but it's basically the same as this. So are we all good with this so far? I know it's a little trippy to see.
Does that modify scores in place?
It does not. Thank you. Yeah, that was the next thing. So while this for loop takes scores and modifies it in place, like Madeline said, a list comprehension, this here is an object in itself. It'll just print it out to the console like it did up here, unless we actually assign it to something. So I would have to go scores is equal to that in order to actually save it. And I don't want to overwrite scores, so actually I think I already have, but you get the idea. So I can get rid of all this. Whoa. You have to import it again. That one time I hit enter when I shouldn't have, just like messed everything up. I'm sorry. Scores is equal to. Now if we look at scores, exactly the way we want it. And that being said, we missed the 89 over here because of a major thing. So never mind that. Forget I said that. The other thing about list comprehensions, which makes them pretty great, is that, so up here, we use list append, if you remember. So one might think if you want to add stuff to a list, you could go for thing and thing, x append each time for each iteration. The thing is, this is actually really slow for super large operations. I don't know if I can really demo that here. So my computer's only so strong. But if you're working through like this massive file of genomic data with millions of records in it, every time you use the append method, so if I had, I don't know how to demo this here, but if I use the append method within an iteration, within a for loop, every time Python went through that iteration, it would look up the list again, which really slows things down. Whereas the list comprehension doesn't do that. So if you're doing massive operations, not only are list comprehensions way more compact and nicer to look at, they're actually way, way faster. I can't demo it here, but just the other day in the lab, I had this operation that went through SNPs in this massive chromosome file. It was taking about 30 minutes. My supervisor was like, make a different file and add a list comprehension instead. And it took 6 seconds. And then he laughed at me for not doing it earlier. But yeah, list comprehensions are great. And I highly recommend using them a lot, all the time, etc. Cool. Are we all good with that? Are there any questions about list comprehensions, list operations? Doing for time. Okay, so just to put it all together, the right way to import that file all along with a list comprehension would have been this. So with open scores.txt read as my file, we should have gone scores is equal to, and then start the list comprehension. We know that they were all imported as strings, so we would just go integer number, so that would convert them in their tracks as they're imported for each number in the original command we had, f on my file dot read split. And that would have immediately given us what we wanted. And now they're all integers. So I'll leave that up for a second. All right. Cool. So that's it for the score section. You can stop worrying about test scores now. The next thing I wanted to talk about that I actually find quite useful for longer scripts are called control flow tools. So let's say we have a for loop, or not even. Let's say we have a list called my list with a bunch of numbers in it. And let's say we want Python to go through this list and just print out the even numbers, for instance. So Python's got this handy thing called the modulus operator, which some people are familiar with, some people are not, which basically divides the first number by the second and then returns the remainder. So 2 divided by 2, 2 modulus 2 should give you 0, whereas 3 modulus 2 should give you 1. So it's a cool way to check, for instance, whether a number is even or not. So we've got our list up here. Let's say we want to run it through a for loop and have it just print out just the even numbers. A useful way to do this is by using continue. That's the first control flow tool I'll talk about. So just that statement counts as the tool. So we could go for each number in my list, if then number modulus 2, so if it's even, is equal to 0. The double equals tests for equality, whereas a single equals assigns things. Then print the number. Else, and this is where continue comes in, continue. And what continue does, here it just printed out the even numbers from our list up there. So the way Python evaluates this is it'll look at the first number and it'll do the test we have here. So it's checking, is this number even? If it is, then print the number. And that's, that's all well and good. But when it hits, let's say 3, it doesn't pass this block, so it goes to else. And what continue does, continue just tells Python, skip this and go straight to the next operation. The other thing about continue is, so let's say if we just wanted the odd numbers, it immediately stops that loop and resets it. It won't execute anything, Python won't execute anything below continue. So if we go for number in my list, if 2 is equal to 0, continue, else print the number. So you might expect that, oh, Python's going to hit an odd number. It won't pass this. No, wait, this is totally wrong. Please ignore that. I totally goofed. Right, sorry, yeah. There, okay. So here, when it hits, when it finds an even number, it resets the loop and it prints the number because this is outside of the conditional. But if we put this in here, then we get nothing. That's because it evaluates this whole block as 1 and it hits the continue thing first. So that means that print num is not evaluated. It's immediately like, all right, let's stop this in our tracks and go immediately to the next iteration. And that's why continue can sometimes be handy because you can put code under that you don't want to run if something is not met, but you do want to run otherwise. The next one is pass. Yeah. Right. So pass does nothing. Like Here, I'll just type it out. So pass is the next one I was going to talk about. So if we just do the same thing, but in place of continue, we put pass, actually print stuff. So whereas continue will stop the loop right here and immediately go to the next iteration, pass doesn't actually do anything. Pass, I like to think of pass as a placeholder to kind of make like alternative cases explicit. So for instance, one way to do that would be, so let's add a string to our list. So we'd use append again. Hello. And we can see that it's at the end of our list over there. So if we go for item in my list, if is instance, so again, checking for the type again, item is an integer, print the thing, and we could just leave it at this, and it would just print the numbers. It won't print the string because the string just won't pass this. But sometimes it can just be helpful to go if is instance item string print or pass. And what this doesn't change the evaluation of it at all. But let's say I'm looking back at this like 3 weeks later. When I look at this, I know that this loop might end up taking a string and it will ignore it. So it just makes things more explicit. And one thing I learned is like always document your code and make things explicit because you're going to be your own collaborator down the line. So if you look at a script months and later and you miss something and it actually ends up being important for some reason, that would tend to suck. So that's mostly how I conceptualize pass. I don't know if other people use it for more interesting things. If there is something else pass can do that I don't know about, like please feel free to shout it out. But that is how I think of pass. And that's why I think that's different from continue. The last one, the last control flow tool, and unlike pass, this one actually does something, is break. And break is a little extreme, as the name might imply. So for item in my list, so let's say we want it to print out the first 3 items here, and when it hits 4, actually, you know what, I'll just go ahead with this and yeah, if item is less than 4, item else break. What this does is it goes as far as 3, and then as soon as this is not evaluated, this evaluates as false, it's going to go on to the next thing, which is break, and then it just stops. It doesn't go any further than that. It doesn't even try iterating through more things. It'll just stop, which is good for us on this purpose because if this had hit the string, we would have gotten an error. So that's what break is useful for. Whereas continue will be like, all right, let's stop this loop and immediately start the next one. Break just ends the loop entirely. And that can also be handy if you've got a really long script with a bunch of for loops going for them. So, yeah.
Can you have an else where there's nothing in it?
Where there's nothing in it? Let's find out. I think it should say expected something after but yeah. Unexpected end of frame, that's what EOF stands for. I think it expects something. That's also why path is handy. So yeah, Python needs to have something there, otherwise it's just confused. The other thing is like if I left this empty and then I did something else here, like 1 + 2, it might try to evaluate this. It might try to evaluate this as part of that, but then the indentation's off. So I advise against it. Anyhow, right, those are 3 I wanted to talk about today. Are there any questions about control flow tools? What they can be used for, all that stuff? Cool. All right. So the next thing I want to talk about are, seeing as we do have time, surprisingly, are assertions. And these are something I use very actively in my research because often when you write a long script, basically the concept behind assertions is putting in ways for accounting for edge cases that might propagate through your script when you don't want them to. And what assertions will basically do is just stop something in its tracks. So let's actually do this so it's more explicit. So let's say we have this function that takes 2 numbers, multiplies them both by 2, and then add them together. And we'll call it sum doubles. Do we know what's going on here? Are we all cool with defining functions in Python? No? Oh, okay, cool. So we'll just write that real quick. Multiplies inputs by 2. I would advise always doing this for functions. It's handy to have a bit of documentation. So we'll go, our return of what we want the function to return will be x times 2 plus y times 2, and then we'll return that. And that's all well and good. We could go sum doubles, 2, 3, and we expect what? 4 plus 6, which is 10. Yay, math. But, so let's say we have that as part of a really long script. It's like taking data at the top and running it through a series of operations, and sum doubles is somewhere in the middle and it does something super crucial. Let's say you read in the wrong file, or something happened to you like what happened with us with scores earlier, where a bunch of numbers are read in as strings for some reason. So how would sum doubles handle that? So what if it got these two as arguments? You'd think it'd like break or complain or something, but no, Python actually allows you to do this with strings for some reason. And if you have downstream functions after sum doubles that expect numbers, this would kind of suck. So you really don't want this to happen. One handy way to counter this, though, is the assert function, basically. So we could write out sum doubles once again. But this time, at the very top, we could say assert that. I'll just write this out first and then explain it. Is instance and here what we're saying is, so first thing to know about assert is if whatever's inside it evaluates to false, it's going to start screaming. By screaming, I mean it's going to immediately stop the script, like the entire script. So what this actually means, so we'll start with the is instance. So this is saying, is x a string? If x is a string, it's going to return true. And then having a not behind that will just convert that to a false. And if you have any false going on in assertion, in assert, it's going to, like I said, break the script. And links basically a similar evaluation for the second argument in our function. So what this basically says is make sure that x is not a string and y is not a string. And if they are a string, like stop the script right away. So we could go sum doubles, 2, 3, as we did before, and that's just fine. We could even do it with floats, for instance, because it's not looking for floats. And that's also fine. Carly, do you have a question? Cool. But if we try to feed it a string this time, this is a string. There we go. Notice the error message. It specifically says assertion error. That's an error that we kind of willed into existence by putting that in there. It points directly to that line, and by assertion error, it just means that this statement evaluated to false. And so it just stopped the process entirely. There are more assert functions as far as I know. I think there's one called assert not equal that's got some funny caps in it that I don't know about or don't remember. So you could be more specific in these, but I just, in generally, my own script, I like to litter them with assertion statements that make sure that everything is going the way it's supposed to. Because it really sucks when you've got a big analysis, you leave it on overnight, and you wake up and see something you really didn't want to because you fed it the wrong input file. So assertions should stop a script right in its tracks with this exact error pointing to where it went wrong. So they're super handy if you're coding for research purposes. But what if, what if we expect a certain error, but we want Python to ignore it? Or let's say we're going through a series of data points, and we want Python to say, do this, but if you encounter this thing that should raise an error, like totally ignore it, and then just keep moving on. So Python also accounts for that. So to that end, let's create a list, a new list, 3, A, 4, 5. As we all know, lists can contain items of different types or objects. So what if we tried to do a for loop over this list and try to multiply everything in it by 0.5? If you multiply a letter by 0.5, that's probably not going to fly. But let's try it anyways. Turn out the first 3, and then we hit this error. And then it just broke, as it would. It's complaining that we can't multiply a sequence that's not an integer, we couldn't multiply that by a float, 0.5 being the float. So what if we wanted Python to actually go through this list, completely ignore A, and then evaluate 4 and 5 as well? And the way to do that is by using the try except structure. So we would go for item in new list, try, and then go print item 0.5. And then we go except. And here you have to know the error message you're expecting. So in our case, it's type error. So you would go except type error. So it's like if you hit a type error, do this. And we're going to have it say print I ignored item. What this does is it makes it go through the numbers. When it hits the string where it would have broken, instead Python's like, okay, that's our exception. It's raising a type error, but the user said, if this happens, then say I ignored this. And it totally does, and then it just continues on with the loop. So try except is also super handy if you've got some kind of processes going on, and you fully expect an error in some way, but you just want Python to ignore it or deal with it a separate way. So yeah, they're also pretty great. It seems I rocketed through my material faster than I thought. Are there any questions about try except or assertions? Has everyone followed along so far? Was I a little fast? Or did you miss anything? Do you want me to go back to? Yeah.
I have a question with assertions. So the error message looks like you could put an error message yourself there. Do you know how to do that? Like, can you make the assertion error be like whatever text?
Oh, let's find out. Help. Any of the brackets there? Nope. How do you get help for function again, Elliot?
It's a keyword.
I what?
I don't think you can get help that way. But anyway, you put a comma and put the string in.
Oh, that would make sense. Assert false. This failed. That's what we expect, right?
Well, you don't need a parentheses.
Oh, what parentheses?
What's the parentheses?
Like this? This is a syntax?
Yes, that's it.
Huh.
No, we're both.
I thought that'd be a very Python 2 thing to not have brackets there. Oh, parentheses, sorry. Cool. So then if we did that up here, we would remove the parentheses here. Is that right?
Yeah.
And then, comma, you gave me a string. Oh, wow, it totally works. Cool. All right, the more you know. Any other questions? Yes.
What's like Python like vectorizing?
Vectorizing.
Like rather than going like item by item, you just do it all on the vector.
Like in parallel? Or oh, yeah, you would probably do that in NumPy. So
So
NumPy,
it's not in like base.
no, not that I know of. I don't believe so.
Maybe, so this comprehension, I don't know where the loops are in this comprehension. I don't see.
Kind of, I think even the generation of list or like the process of list comprehension is like stepwise, itemwise.
But all of them, like even vectorization is stepwise.
Yeah, yeah, I guess if you reduce it to that, yeah.
So maybe this comprehension is, I think this comprehension is basically the same as all of them.
It is. It's just
But it's
it's
much faster.
yeah, it's faster because I don't think it like looks up the object each time
I think
as opposed to something like append. Wait, what?
I think it's pretty much the same as all of them.
List comprehensions?
Yeah.
Oh, they're way faster. Like they're faster than append specifically. If you're creating new, if you're adding to a list, then it's way faster than append, insert, or extend, or any of those. I don't know about list operations in general. I've never actually tested that. I think the way to test something was time it, right? In Python,
So
like
it's
that.
only faster than that, it's probably, because we dynamically do it, right?
Wait, sorry, I missed that.
It's like, if you do a pen, I think you always add a new like addition in the list, so you have to go with the memory.
Yeah,
Instead of having the entire thing as for me.
right. The way I understood it though was that like for each iteration, Python like the way it was explained to me was basically Python going to the computer going to Python and being like, yo, I want to access this list, and it's like, cool, and it adds a thing, and then it resets and goes, yo, I want to access this list, and then that's how I understand it. I don't know the fancier terms behind that, but like, I've literally seen, because I was writing that thing with a pen and it was taking about half an hour, and it happened in 6 seconds, the exact same for loop in a list comprehension. So there's something about lookups that I don't have the technical know-how for that does speed that up if you're growing a list. I don't know about other operations. Are there any other questions? Anything like tangentially related to the stuff that maybe I could try and cover or crowdsource answers to?
The attributes versus methods.
True. I didn't really go into attributes. So I talked about methods up here. So append was like the golden method of the night. But attributes they kind of describe an object more so than do something to it. It's a good off-the-cuff example of an attribute. I only ever use them in pandas. Types of function you run on something, though. Oh yeah, it looks like
There.
true. Oops. I think these are all methods. One of these? Yeah, me either. But for instance, yeah, the underscore ones, I'm not sure. I never really worried about them. Sorry.
There are special methods that, like GE defines like greater than equal, but you can repurpose it to do something else.
So it's generally for like Python's internal use, kind of, that you can explicitly do stuff with it. Is that right?
Yeah, I mean like modulus you could use as use it on a string and it just string formatting, right? So that would be like one of those methods might be re-implementing modulus on a string so that instead of trying to take the remainder of the string and the numbers that doesn't make any sense, it will format it as a natural thing.
Is that what you meant? Because I didn't do anything.
Yeah, well, you have to put some percent in the string too.
Oh, like that?
Yeah, like
Percent D. Oh, neat. So it's like substitution.
yeah.
Oh, so that's probably like one of these
That's like
methods.
one of those will implement that.
That is very nifty. Does that work for multiple characters?
Well,
Let's try it.
You refer to a certain number.
It's just a single thing.
So it's different, like the D is one, S is one, and like each of the means of them is a different string format.
Oh, okay. So kind of like R and W also mean something within opening files. Cool. Okay, so let's say substitute stuff in a string, I guess. What I learned, after what? Float.
You just put in.
Whoa. Oh, okay. Cool. Oh, okay. Well, the way I've done string substitution was like test dot format T is equal to capital T. That didn't work. What? Oh, right. Yeah. Sorry, I forgot about that. That, right? The braces, yeah. But that was how I'd done string substitution in the past, but I guess you can do the modulus thing as well.
I think this is the
Yeah.
The second
This I find is really nifty if you're using something like subprocess and feeding commands to the shell, but you have this whole set of commands you want to do that change each time. So you can have like your command skeleton like this and then stick it in the body of a loop. So I don't know. Because you could technically go like letters A, B, C. This is a crude example. For L in letters, print curly braces T format. So each time it like evaluates the string differently. So if you pipe that into something like for subprocessor, I don't know why I imported subprocess, actually didn't really need to do that. But like anything else where you've got like a series of slightly different commands, I find this a pretty cool way to automate them. Just have it change the string and then feed that to something else down the line. So that's also a pretty nifty trick. Yeah.
Can you do that with like not sub-process but actual Python commands if you want to change the variable name this way?
Possibly. Let's try it. Although I think Dan had a question. If it's a quick question.
Yeah, I'm just curious, is really so much like if statement stuff. How do you switch statements in Python?
Switch.
Case and such.
Oh.
Yeah. What is it in Python? The
You want to use an if or you use a dictionary, dictionary that comes to that function.
oh, shoot.
Yeah, that's why I never heard of
Okay,
it.
sure.
Is that a Java thing?
Yeah, JavaScript traffic.
Gotcha. Switch. Huh. Okay, so let's try the. Well, I'll just copy this here and then. Well, no, because this is a string. I don't think you can assign something to a string. But sorry, what? You could do it to strings, but I suppose you could set that to something else. So you could be like, my word is equal to that, and then go print my word. And print could be, I suppose, anything else, right? So if this was something that actually made sense of these, I don't know, what's a good example? You know, like, my point is like you could assign it to something and then feed that as an argument to something else. So possibly that way. That's one workaround. True. But for instance, let's say you've got a bunch of files in a directory and you want to do this, because I'm pretty sure there are easy ways to do this, like this really long-winded way of piping them all to something. That's the easy way, right? I used it about an hour ago. That's something I forgot. Cool. How much more time do we have? I think that's the hour. Are there any final questions, comments, concerns, queries? Did I say suggestions? All right. Thanks, everyone.